Hello everyone, and welcome to the 6th video in the WebGL TypeScript Engine tutorial series. Today we're actually going to talk about textures and how to load those up and get those onto our sprite that we've created. And we're also going to talk a little bit about assets and asset management and how to load those things and how to handle some of the problems with loading assets online and some of the things that you can actually run into along the way. So whenever you're dealing with an asset that has to be pulled, and an asset can be anything like a text file or in this case an image, with WebGL or the browser in general, in order to get that you have to pull it from the web server that the project is hosted on. And that actually takes time to download that asset. It's not something that's instant, like you can load it off your local computer. It takes time to download. Now, the download may be very, very quick, but because it's not instant, it has to be handled with a few things in mind. So, whenever you create a request over the web, a response comes back when the server serves up that response to your request. And basically there's a request that's made from your local machine to the web server. The web server has to take time to process that, and then it sends as a response what you requested. What you've requested might be a web page, it might be an image, whatever that thing may be. Time elapses in between each one of those requests. So to load a texture into WebGL, we first need an image. And to get an image, we have to download it. So to download the image, we should probably come up with a standardized way to do this. And since we're creating an actual engine here, we want to focus on reusable code. And so I really want to avoid just doing sort of a one-off sort of texture loader for this. So what we're actually going to create first is something that I call an asset manager. And this is going to be a very simple asset manager, but what it's going to do is it's going to be responsible for reaching out and downloading assets, and it's also going to be responsible for notifying other parts of the engine that those assets are ready to actually be downloaded. Before that, we need something called a messaging system. And what a messaging system is it allows us in a very decoupled way to send data or trigger an event from one part of the system to another part of the system without having either part of that system know about one another. And so this is a very important concept in software development as a whole, but especially in game engines. Messages are one of the best ways to make things happen in different portions of your engine while keeping them all decoupled. So there's a lot of steps that we have to actually follow in order to get to the point where we can load a texture into our sprite. So I have a feeling that this video is going to be a little bit long, so I would recommend go get a cup of coffee or maybe a Mountain Dew or something, and sit back and let's get coding. So the very first thing that I want to do is in core, I want to create a new folder, and we're going to call this assets. And in the assets folder, we want to add a new TypeScript file. And we're going to call this one asset manager. And in that file, we want to say namespace TSE and export class asset manager. And the next thing we want to set up is a private constructor, because this is going to be what we call a static class, which technically TypeScript doesn't support, but we only want to access this statically. We don't want to have to rely on an instance of this existing in order to actually do stuff with it. So we want to hide the constructor so that we don't accidentally call it at some later point. And the next thing that we're going to want to do is we actually need to declare a couple of interfaces. And so what I'm going to do is I'm actually going to create a new folder under the new file rather under the assets folder. So a new TypeScript file, and we're going to call this iAsset. So a standard naming convention whenever you're dealing with interfaces is to put an I in front of whatever the class name is going to be, because it denotes it as an interface. And an interface is different from a class in that you define the structure of what that thing is going to be, but the implementation is not there. So when we talk about interfaces, you can think of this like the steering wheel of a car. You know that a steering wheel of a car has certain properties, right? It has a radius, it has X amount of degrees that it can turn, and every steering wheel has that. Every steering wheel has a horn, right? But some steering wheels might be leather wrapped, some steering wheels might be made of plastic or wood, some steering wheels might have a chrome horn in the center, some steering wheels might have an airbag that's part of the horn assembly. So there are lots of details that can be specific to a type of steering wheel, but there are other details that all steering wheels have. So what we want to focus on is that set of properties that all steering wheels have, or in this case, all assets. So when we talk about an asset, the first thing we want to do, let's go ahead and scaffold this real quick. So namespace TSE, and we want to export interface instead of class here. We want to use the interface keyword. We want to say iAsset. And when we talk about an asset, what we really want to do is figure out what these properties are that all assets have. So the first thing that they're going to have is going to be a name. That's going to be a string. And the name is also going to double as the file name, or the URL. We're actually going to use those as one and the same. And the other thing that they're going to have is data. And the data can be anything. And so we're going to declare type any. Any in TypeScript is a open-ended type that you can literally attach anything to, and it's open and flexible. So all assets will have a data field, but we're not defining here what type of data that asset is actually going to contain. Now, the thing that I want to do next is I actually want to mark these as read-only, because once we load an asset, we don't want to be modifying what the asset actually contains, and we don't want to be able to rename it. So we're going to mark both of these things as read-only, which in interfaces basically means that we can get the value, but we can't set it. And we're going to need another interface, which I want to put in a different class, different file rather. So we're going to add another TypeScript file, and we're going to call this one iAssetLoader. So let's scaffold this one out. Namespace TSE, export interface iAssetLoader. And what an asset loader is it is responsible for loading a specific type of asset and populating the asset data, and it knows how to handle that internally. So all asset loaders have, again, a certain number of properties that are common to all of them. So we want to go ahead and set those up in an interface so that we start to have reusable and uniform code. So the first thing is going to be another read-only property, and this is going to be called supported extensions, and that's going to be a string array. And when we say supported extensions, we're talking file extensions here. So it might be .png or .gif for an image loader, for example, or .txt for a text asset loader. And the next thing we're actually going to declare here is a method that all of these asset loaders have. And so that method is going to be called loadAsset, and it's going to take in a property called asset name. which is of type string, and it's going to return a iAsset. And so that's really the only thing that all the loaders have in common, is just those two properties. So now that we've got those two things set up, we need to set some stuff up in our asset manager. We actually need to set up a couple of static properties, right? So static properties being properties that don't require an instance of this to actually exist. So we're going to set up a private static, and we're going to call this underscore loaders. And the type of this is going to be an array of iAsset loaders. And we're just going to initialize that to an empty array. Second thing that we want to set up is a private static. We'll call this loaded assets. And this type is going to be a dictionary type, or a hash table. So it's going to be an object, and then inside that object it's going to have we'll call this name of type string, and so that'll be the key. The value will be of type I asset, and we want to initialize this to an empty object. Okay, and so what this will allow us to do is access the asset by its name in a dictionary. The other thing that we're going to need is a public static initialize method that returns type void. And after that, we want to have another public static register loader. So this is how we're going to tell the asset manager to add a loader for us to be able to use. So that's going to take a loader, which is of type iAsset loader, and that's going to be return type void. So in register loader, all we're going to do is say asset manager dot loaders dot push loader. Now we could check this to see if it already exists, but for our engine we don't really need to do that because we are fully aware of all the loaders that we're going to use. So I'm not going to bother error checking this. We're just going to assume that the loader that's passed in is unique. We want to stub out a couple more methods. Let's also create a public static load asset, and we're going to take in asset name type string, return void. Not going to fill that out yet. And then we're going to create another public static, and we're going to call that is asset loaded. And again, it's going to take in the asset name type string and return a boolean. There we go. And for this one, we're just going to return asset manager dot loaded assets, and then we're going to say the key is going to be asset name, and then we're going to say not equal to undefined. So basically, if our dictionary has an asset with this name defined, then it's loaded. Otherwise, it is undefined. It returns undefined. I'm sorry, it doesn't return undefined. It returns false if it's not loaded. So one more thing is another public static get asset, and again asset name string, and we want to return an iAsset. And what we're going to say is we're actually just going to copy this line right here. We're going to say if it's not undefined, then we return that asset. Else, we say asset manager dot load asset asset name. So in other words, If the asset doesn't exist, we attempt to load it. And if this happens, obviously undefined winds up getting returned. So let's just be explicit about that. Return undefined. So in other words, if the asset exists, it gets returned. If the asset does not exist, we load it, but then return undefined. And I'm actually going to hold off on filling out the rest of this for right now because we need one more piece of the puzzle before we can actually finish this. And what we need is the message system that I referred to earlier. So what we actually need to do is there's a couple components to the message system that we actually need to create. And so what we need is we actually need a message class that holds the message data that's going to be sent around. And then we need some sort of manager for that message class to send the messengers. And this message manager will allow for certain classes to subscribe and listen for particular messages so that when a message is sent with a particular code, that class knows how to respond to that. So let's go ahead and set that up. So under core again, right click, add new folder. We're going to call that message. And under message, we are going to create a TypeScript class, TypeScript file rather, also called message. Namespace TSE, export class message. And messages are going to have a few public properties. So the first one is going to be a code. This is going to be what the messages will subscribe for and listen for. That's just going to be a type of string. You'll see how this comes together in a minute. The next thing we're going to have is we're going to have the context. And this is going to be a type any because we don't want to limit the type of data that can be sent with a message. So the context is just free-form data. You can send anything along with a message, and it's included along with that message. So when the handler of that message receives it, it can look at the context and should know what to do with it. And the last thing that we're going to do is include information about the sender, which is also of type any. So any class can actually send a message. And there's actually one more thing that we're going to need, but in order to add that property, we need to create an enumeration. So let's export an enum called message priority. And we're going to create two priorities here. We're going to create a normal and a high. And I'll explain more on what that's for in a moment, but for now, let's just go ahead and add public priority message priority. Okay. And for convenience sake, let's go ahead and add a public constructor that takes in some of these properties. So we want to say code string and then sender type any, and then we want to make the context optional, type any, and the priority that's going to be of type message priority, but it's going to default to message priority dot normal because that's what we want to use 90% of the time. Okay, so we can send or we can create a message with as little as a code and a sender. So we're always going to want these pieces of information, so those things are required. So let's just copy over those properties. This dot code equals code. This dot sender equals sender. This dot context equals context. And this dot priority equals priority. Okay. So that's pretty much all we're going to have to do at the moment for our message class. We are going to have to add some things to it, but before we do that, we need to actually create our message handler, or our message manager. And for the purposes of this engine, I'm actually going to call it a message bus, because a message bus is going to be what's responsible from transporting a message from one location to another. So we'll create a new TypeScript file in message, and we'll call it message bus, and we'll scaffold that, same as usual. Export class message bus, and this is going to be a class that is statically accessed, so we want to hide the constructor. And the message bus is actually going to need a couple of interfaces in order to actually work. Well, actually one interface and then another class to actually work. So let's go ahead and add those things. So the first thing that we want is a new TypeScript file, and we're actually going to add an interface for message handlers. So a message handler is something that can subscribe and listen for a message. So we're going to call this iMessage handler, and for brevity's sake, I'm going to copy that, scaffold this, TSE, export interface iMessage handler, and it's going to have a single method that is called onMessage, and it's going to take in a message, and its return type is void, and that's it. So anything that implements this interface must have a onMessage function that looks like this. And that's actually all that we need for iMessage handler, so I'm going to close that. The next thing that we need is a way to hold message subscription information. So I'm going to create a new TypeScript file, and we're going to call this one message subscription node. And again, I'm going to copy that, scaffold this file, TSE, export class message subscription node. And this one is going to contain two public properties. So it's going to contain a message, and it's going to contain a handler. So an iMessage handler. And let's just add a public constructor that takes those properties in. So we'll say message handler iMessage handler. Okay, this.message equals message, oops, lowercase message. This.handler equals handler. Okay, and this just simply acts as a container to hold those two things. That's all this class does. So I'm going to go ahead and close that one too. So now in our message bus, we actually have a few things that we need to add in order to set this whole thing up. So the first thing we need to add is a list or a dictionary of our subscriptions. So when we subscribe for a message, we need a way to hold that, and that's going to be a dictionary of codes and iMessage handlers. So we're going to have a private static, and then we're going to call this subscriptions, and that's going to be of type, it's going to be an object type. We're going to say code of type string, and the value of that is going to be an iMessage handler. It's actually going to be an array of iMessage handlers, and I don't know why this keeps auto formatting like that. I don't want it to do that. There we go. Okay. And initialize that to an empty object. The next thing that we're going to need is a message queue. So one thing with messages is if you send a lot of them in a single update, the time to process those messages can sometimes take quite a bit. If you have a lot of messages, say thousands of messages being sent. Now, granted, a design consideration of that might be that your code that's sending thousands of messages per frame, there's something seriously wrong if you're doing that. But for performance reasons, we actually want to limit the number of messages that can be sent per frame. And that's why we have the message priority. So we have the high priority and we have the normal priority. So normal priority messages, we can limit the amount of those that get sent because it's not absolutely critical that the message be handled on that same frame. Versus high priority, we want it sent and executed immediately. So we need a queue to handle those normal messages in case we wind up sending, let's say we have a limit of 10 messages that can be sent per frame. If we have 20 that are queued up, then it should take 2 frames to actually send all those messages so that they get processed. And so we need to set up a queue to actually hold on to those messages until they can get processed properly. So we need to set up a private static. We're going to call this normal queue message per update. And that's going to be a number. And let's go ahead and set this to 10 for now. I think we should set it a lot higher than that, but for now we'll just set it to 10. And then we also need a private static, and we're going to call this normal message queue. And that's simply going to be a collection of message subscription nodes. And we'll initialize that to an empty array. Okay, so the next thing that we need to do is we need to have the ability to add a subscription. So we're going to create a public static add subscription. And we need to take in a code string and a handler, iMessage handler. And that's going to return type void. And what we need to do is we need to look at if message bus dot subscriptions key code, since code is the actual key, is not equal to undefined, then we need to set this to an empty array. So what we're basically doing is we're saying we need to set up a container of handlers for this code to be associated with, if it doesn't exist. So the next thing we want to check is to make sure that this handler and code combination doesn't already exist. So to do that, we want to say if message bus subscriptions code dot index of handler is not equal to -1, meaning the array that's here contains this handler. If that already happens, we don't really want to do anything. We're just going to say console.warn, and then we'll say attempting to add a duplicate handler to code, and then we'll say code, oops, and then we'll say subscription not added. Right, so we'll just warn that that's what's happened, and we'll not do anything about it because we don't want to register the same thing twice, and you'll see why coming up in a bit. So the next thing we'll want to do is we'll say message bus subscriptions code push handler. So if it doesn't exist, we want to push it to the array, and that's it. Now it's registered. There's a subscription made for that handler for that particular code. And so the next thing that we want to do real quickly is we actually want to take a copy of this and create a remove, because we're actually going to need the ability to unsubscribe. So I'm just going to rename this to remove. And if we have this situation where, let's actually change this to equals undefined, triple equals undefined. Then we're going to take this console warn here, and we're going to say cannot unsubscribe handler from code because that code is not subscribed to, right? And then we're actually going to go ahead and return. And then down here, we actually want to say if this isn't found, or I'm sorry, if this isn't not found, then we want to go ahead and, whoops, just copy this again. And we want to say, actually, I'm going to need, so let's say let node index equal that, right? So we return the index of that. And then here, we're going to say if node index is not equal to -1, which means it's been found, then we actually want to message bus.subscriptions.code, and then we want to splice, which is basically saying take this out of the array, and we want to splice starting at node index, and we want to take out one element. And there is no else, because we don't want to do anything if the node's not found. We're just not going to do anything. We're just going to ignore it. So the next thing that we need to do is we need to post. So public static post, and we need to post a message, and that's going to be return type void. And what I'm going to do is I'm actually going to post, I'm going to output some debug information. So I'm going to say console.log message posted, just so we can kind of see this, and then actually output the message itself. And then what we're going to do is we're going to loop through. We're actually going to see if we have any handlers first. So what we're going to say is let handlers equals, and then I'm going to say message bus subscriptions, and we're going to look at message.code, right? So we want to see if we have any handlers for this particular code that was passed in. So first off, if handlers is undefined, we don't want to do anything, so we're going to return. Otherwise, we want to loop through each one of those things. So we want to say let h of handlers. For those of you that are not familiar with the of keyword, if you wanted to say in, it actually turns this into an index, which in this case is a string. So if we say let in handlers, this is a string, and you have to say, in order to access it, you have to do this. But if you use of, it treats it almost like a for each loop in other languages. So it actually will get you the proper handler of that. So if we say let h of handlers, h is actually a handler, not the index. So what we're going to say here is we're going to say if h dot prior, if message dot priority equals message priority dot high, we want to send it right away. So what we're going to do is we're going to say to the handler h dot on message. So we're going to call on message directly and pass it the message. So whenever you send a high priority message, it's immediately going to call that on message for that particular handler. Otherwise, we want to go ahead and queue it up. So we want to say message bus dot normal message queue, and we want to push a new message subscription node, pass in message, and pass in the handler, which in this case is H. And so that's going to queue that message up to be sent later on. And that's all there is to posting. So the next thing that we need to do is we need to add a update loop to this. So we need to say public static update, and we're going to say time, and we're going to, that's going to be a number, whoops, number, and this could be a void. And what we're going to do is first off check the length of the queue. So if message bus dot normal message queue dot length, if it's 0, we're just going to boot out. Otherwise, what we want to do is we want to get the message limit. In other words, get the total number of messages we're going to send. And we want to determine whether that's the actual limit that we set up here, or whether it's the number of messages. Because if the number of messages queued is less than this, then we want to use that number instead. So we're going to say let message limit, and we're going to say math.min, and we're going to say message bus dot normal queue message per update, or we're going to pass it this length, and it's going to return to us whichever of those two is smaller. And then we can loop through it. So for, and we can say let I equal 0, I is less than, let's say message limit plus plus I. And now we can say, let's just go ahead and get the node from that. So let's say let node equals, and we want to take the first one off the stack, or out of the array. So we want to say message bus dot normal message queue dot pop, which is going to remove the first element from the array and return it for us. And then we want to call on message against that node. So we want to say node dot handler dot on message, and we want to pass it node dot message. Yeah, node dot message. Right. And that's it. So we just need to make sure that we call this update all the time, and and this will process our queue for us. So I think that about does it for the message bus class. It's not really all that complicated. It's more just taking the time to actually set it up than anything else. So the next thing that we want to do is we actually want to go back to the message class, and we want to add some convenience methods to message, because we don't have to remember whether or not we have to call message or message bus in order to actually send a message. So I want to add a couple of static methods to message as a convenience. So we're going to say public static, and then we're going to say send, and that's going to take code of type string, sender of type any, and an optional context, also of type any. It's going to return type void. And all this is going to do is it's going to call message bus. Oops, message bus.post. Going to create a new message, and we're going to pass it code sender context. And one thing that we're going to do is we're actually going to hard code in here message priority dot normal. So by default, if we just call send, we're going to send a normal priority message. Next thing we're going to do is create a copy of this, and we're going to call it send priority, and we're going to change this to high. So if we call send, it sends a normal message. If we call send priority, it sends a high priority message. Next two things that we need, the last two things that we need actually, are public static, and we're gonna say subscribe, and that's going to take in a code string and a handler, which is of type iMessage handler, and return type's void, and it's simply going to call messageBus.addSubscription code handler, right? So now we can just say message.subscribe, and I'm going to copy. Whoops! Why do I have? Oh, I misspelled handler. There we go. Okay, so I'm actually going to just copy subscribe, and I'm going to say unsubscribe and remove subscription. And so now we have our convenience shortcuts all set up. And that is all that is required for our message system. So this allows us to very conveniently and easily send messages across the system in a very decoupled way. And our asset manager is actually going to require this. So let's go back to our asset manager, and we've scaffolded some things here. And so what we actually need to do is we need to fill out some of these methods. So let's go ahead and start with load asset. So I'm going to let the extension equal asset name dot split. And what we're going to do is get the file extension here, right? So we're going to split it by the periods, and then we're going to pop the last one that's added to that array, which is going to be the last index of the period, to lowercase. Right, so this is basically going to split the string by periods, grab the last section that was split, and then to lowercase it, and then we have our extension. And then I'm going to say for let L of asset manager dot loaders, and I want to say if L dot supported extensions dot index of extension is not equal to -1, meaning it exists, then we want to say L dot load asset name, and we want to return. So that way it boots out of this loop early. So in other words, as soon as we find something that can handle it, we just return, and that's it. And the next thing that we need to do is we actually need to have a callback for the asset loaders to actually call when they've loaded an asset. So create a public static on asset loaded, and we're going to take in an asset, which is an iAsset, and that's going to be a type void. Void. Okay, and what we want to do is we want to say asset manager dot loaded assets, and we want to say asset dot name equals asset. So we're adding it to our dictionary. And then what we want to do is we want to message anybody out there that needs to know about this asset loading, that the asset has loaded. So up here, I'm actually going to create a constant. Actually, I'm going to export that, and I'm going to call it message underscore asset underscore loader asset underscore loaded. And I'm going to set it to a string of that same value. And the reason I'm doing this is so that I can reuse this string without having to retype it elsewhere and mess it up. So on asset loaded, I want to say message.send message asset loader asset loaded, and then I want to send I want to append to that rather. You know what? Let's add that here. And then I want to just say asset name. So that's the code that will be sent out. So it'll be basically this : asset name. And then as far as the sender, I want to send this. And as far as the context, I want to send the asset itself. So anything that's listening for that message will know to listen for an asset with a particular name. And then the context will be an I asset, and it'll know what to do with it from there. Real quickly, I want to just add a warning to load asset in case we loop through all of these things and we don't actually have a loader that handles it. I want to say console.warn, and we're going to say unable to load asset with extension, and I'm going to add extension to it because there is no loader for let's say loader associated with it. Okay, so let's see, we have I think that is it for the asset loader. So it's not a whole lot that's going on here, but as you can see, we needed the message system mainly for this, so that we have a nice way to be able to notify other things when an asset has actually been loaded. So the next thing we actually need to do is we need to create an image asset loader. So this is the next step in that long process that I started with in the beginning of the video. So I need to create a new TypeScript file, and we'll call this image asset loader, namespace TSE, export class image asset loader. And this one implements iAssetLoader. Okay? And so when we do that, it's going to bleat about not implementing the interface properly. So we want to just go ahead and, a quick keyboard shortcut in Visual Studio, by the way, is if you click on the text that has an error and you hit Control Dot on your keyboard, it'll actually give you in a lot of cases, it'll actually give you a suggestion as to how to fix it. So it says implement interface iAssetLoader. So we're going to do that by hitting enter. And so that very nicely scaffolds some of these things for us, so we don't have to do it manually. All I have to do is add the scope to these two things. And now all we have to do is actually fill these things out. So what I want to do is we're going to turn this property into a get, since it's read-only in the interface. That's the equivalent. So we do that by typing get, putting parentheses here, and now we can just return an array, and we're going to say the types of images that we want to support, or the extensions we want to support, are PNG, GIF, and JPEG, because those are the ones that most browsers actually support. And the next thing is load asset. So what we need to do is say we need a HTML image. So let image, it's going to be of type HTML image element, and we're going to say equals new image, which returns type of HTML image element. Okay? And in that we can say actually before that, we need to set something else up. We need to set up a callback for when the image is loaded. So here we'll say private on image loaded, and that needs to take in the asset name type string and the image of HTML image element, and its return type is any. Actually, its return type should be void, not any. Okay, so what I'm going to do is just output some debug text. So I'm going to say console.log, and I'm going to say on image loaded, and then I'm going to say asset name / image, and I'm going to output both of those things. So asset name image. Just output them to the console so I can actually see the data that comes through on that. And I'm going to say let asset equals, oops, okay. So I actually need something else to hook this up. I need a asset class to work with. So I'm just going to create this right here. Class image asset implements iAsset. And the image asset is actually going to be pretty straightforward. So it's going to be a public read-only name of type string, public read-only data of type HTML element. So this fills the requirement of the interface, but now we're a little bit more specific in saying the data that's contained with this is an HTML image element. Okay, the next thing we're actually going to do is we're going to add a couple of convenience getters here. So we're going to say get width. It's going to return a type number, and we're going to return this data.width. And we're going to do the same thing for height. Number, return this data dot height. Okay. And I'm also going to create a constructor just to make things a little bit easier when creating this. So public constructor, and I'm going to say it's going to take name string and data HTML image element. Okay, this dot name equals name, this dot data equals data. Cool. So now we have our image asset. So now I can go back here to load asset, and I can say let asset equals new image asset, and I can pass in asset name. Whoops, I'm in the wrong place. This should be in the on image loaded. Pass in the asset name and the image. And here's how we actually create our asset to be used later on. And here's where we actually call the asset manager's callback. So we say asset manager dot on asset loaded, and we pass it the asset. Right? So that's what registers it in the asset dictionary. So now in load asset, we can say image.onload onload equals this dot on image loaded bind, and we want to say this, and then we want to pass the asset name, and we want to pass image. Right? And then so we set up a callback for it. So when this image loads, it calls this, which chains it back to the asset manager. And now we actually set the source. And it's important to set the source afterwards, because once you set the source, it actually creates the request to actually reach out to the server and grab the image. So it's the very last thing that you want to do. So we set the source to asset name, and that's it. Okay, so now we're actually done with the image asset loader. That's all there is to it. It's pretty straightforward. All the other ones are going to be structured in a very similar way. And that's really all there is to it. One thing that I want to change, though, is this load asset is returning a type I asset, and it doesn't actually need to do that. We can just set that to void. And I'll go here to the I asset loader and change this to void as well, because we don't actually need to return that. Okay. And the last thing is we actually need to register that loader with the asset manager in initialize. So we need to say this.loaders. Oops, I'm sorry, not this.loaders. Asset manager.loaders. Okay, and then we want to push, and then we'll create a new image asset loader. And that's all there really is to loading an image asset. So at this point, we have it all. We have everything that we need hooked up to actually load an image asset. So I think what I'm going to do, because of the length of this video, is I'm actually going to split this one into 2 parts. I'm going to end this video right here, and I'm actually going to create a part 2 video to talk about how to actually load the textures into our sprite class and get those showing up on the screen. So thank you guys so much for watching. If you haven't subscribed already, please consider subscribing, and I will see you guys in the next video.